right, we're looking to solve this quadratic by graphing. So the quadratic is given to us with just the variables x. The nice thing is that all the variables and all the constants have been put over here to the left side, and this side is 0. So that's really important. If you get a quadratic and it's an equation, you want to get all of your terms to one side, get the other side equal to 0. And then what you want to recognize is that if you're asked to graph this guy, right now, there's no y variable, but we're going to replace the 0 with the y, and then it's going to look much more like something that we have graphed before. So it looks like this guy. If we put the y first, that normally happens, right? X squared minus 2x plus 5. Okay, and then from there, because it's in standard form, I'm going to go with sort of my standard plan, which is to find the axis of symmetry, and that is from x is the opposite of b over 2a. And then I'm going to find the vertex. And then from there, I will either build a table or just use the a value. So I'll do table or a. So let's go ahead and get started. We're going to go ahead and find the axis of symmetry. And I'll start that here. This is another common abbreviation, AOS. So we're going to use this guy. X is the opposite of b over 2a. If I'm looking at my equation here, my b value is -2. And my a value, I don't see it, but it's right there. It's a 1. So what I'll do from there is just plug those numbers in. So my x equals, I always say the opposite of b, but it's a negative b. B is already negative, so that's a -2, which looks weird. So we'll make that a positive in just a moment. All over 2 times a, the a value is 1. Right, so really it's 2 over 2, which is just 1. My axis of symmetry is 1. So there's a vertical line through x equals 1 going through this parabola. Then from there, I'm going to want to find my vertex. So I'm going to do y equals that x value squared, because it's x squared. There's a 1 there. I'm not putting the 1, right? X squared minus 2 times 1 plus 5, right? So this guy, this x equals 1, the axis of symmetry, is going to get plugged in there. So do I have 1 minus 2 plus 5? I could certainly use a calculator. -1 plus 5. Oh, I'm writing where you can't see. I just did all the math there, right? Plugged it in. And now I have my vertex. So my vertex is that coordinate, the x value paired with this y value, 1, 4. Okay, so from there, in order to set up the graph, I either want to set up a table or I can just use my a value. Either is totally fine. I'll go ahead and set up a table. But what's really important is that that vertex goes in the middle. So I'm going to put the x value of 1, the y value of 4 here, and then I will build coordinates around the vertex. So in one direction on x, I'll go bigger, and on the other direction on x, I will go smaller. And I picked up a calculator here because I want to kind of make this efficient. What I'm going to do is into the equation where I plugged 1 to begin with, I'm just going to plug these numbers. So let's see, I'll do -1 to start, squared minus 2 times -1 plus 5. There we go. So that's going to give me 8. I'm just going to go over type here and make all those zeros. Delete gets rid of a single key, by the way, when I need to get rid of just a single digit. Over type that 1 to a 0. Delete this, make that guy a 0. I'm going to get 5. Now, if I did the setup correctly, this is the vertex. I should get those symmetrical values on the other side. It's a really good idea to actually type them in, though, just to confirm that everything's working like it should. And it is, because I got a 5 here. Now I'm going to input 3, and I should get an 8. I do. All right, so now I got points. Let's set up a T-chart here. Vertex is at 1, 4. The A value is 1, so it's oriented up. And since it's 1, it's just our standard growth. So really for graphing, let's see. I did go to -1 on X. I just want to make sure I'm giving myself enough room. 6, 7, 8, 9. Okay, that should fit everything I have here. Okay, 1, 4, my vertex, 1. 1, 2, 3, 4. And then all these other coordinates here, 0, 5, which which makes sense, by the way, because that's my y-intercept. My y-intercept here is 5. 2, 5, 3, 8, 6, 7, 8. Over here, 3. -1, 8. And that, by the way, fits my A pattern growth, right? That from the vertex, I go left and right 1, up 1. From the vertex, left and right 2, up 2. That's the quadratic growth. 1 squared is 1. 2 squared is 4. Here is my parabola. So I connect it with that U shape. It didn't ask for this, but I'm getting in the habit of always kind of doing this. My domain, X is all real numbers, and my range, Y is all real numbers, but it's got to be greater than or equal to 4. Okay, I hope that's helpful on how we go from a quadratic equation that looks like this to solving it by graphing. Oh, actually, I didn't solve. All I did was graph it. Solving was the prompt here. That's actually, I'm glad I threw this back up. We are looking for the x-intercepts. We're using the graph to help us find where the x-intercepts are. And if I look at my graph here, this parabola is not crossing the x-axis. So the solution here is that there is no solution. There are no x-intercepts. There are no zeros. This green parabola does not cross the x-axis. Hopefully that's helpful. Catch me anytime.